Hi, myself Acute Canaria am going to present a presentation on the project conducted on re-engineering proposal of lever safety valve in the class of Computer Integrated Manufacturing at LAMAR University, Texas. The authors are Acute Canaria, Chansi Patel and Harsh Patel. This project is about redesigning of lever type safety valve. It is widely used in any steam generating industries. As an example, thermal power generating industry. A safety valve is a mechanical device which automatically releases high pressurized substance from its reservoir or system, which is generally caused by a chemical reaction, thermal expansion, a heat exchanger tube rupture, the external fire, the cooling system failure, or an ambient temperature changes. This figure shows the assembly of the original lever type safety valve. T1 shows the names of the different components used in it. This table shows the list of parts used in the original assembly. There are a total number of 30 parts including washers, pins, nuts and bolts. The objective of this project is to use PTC Creo Parametric 2.0 in modeling the parts and assembly. We were also supposed to improve the assembly with design for manufacturing and design for assembly methodology, to reduce the number of part count in the valve assembly, to minimize the complexity to manufacture different components, to develop manufacturing improvements that will reduce maintenance or repair service time, design the model for ease of assembly operation, even to decrease the cost and time consumed to manufacture and assemble the valve. We undergone design for manufacturing analysis, and the fulcrum end was redesigned keeping in mind the design for manufacturing guidelines. We use the standardized manufacturing features on the components to design the ease for manufacturing and fabrication. We developed a modular design. This is the bridge end, which is also redesigned to reduce the unnecessary features in manufacturing and which consumed more time in machining. This is the redesign of the mounting block, which is redesigned keeping in mind the less material is used than before. The model tree showing the number of features of original mounting block and the reduction of features in the redesigned mounting block are shown over here. This is the design for assembly for our parts. The valve seat and liner, which were two different components, were then modified into a single component as shown over here. Design for assembly is for design of parts for multi-use. Even the fulcrum assembly, which consists of 7 different components before, was redesigned into a new component which has only 2 parts in it. This is the bridge assembly, in which the same design for assembly is used to reduce the number of part count in it. This is the table showing the part reduction with design for assembly. There were total 16 number of parts used before, which were then redesigned into 5. So there was a reduction of 11 number of components, 11 components. This figure shows the redesigned safety valve. The assembly shows different parts, the name of the different parts. This table shows the redesigned list of parts. The new assembly which is redesigned has the total number of parts, that is 19, which were previously it was 30. This figure shows the exploded view of the assembly, of the original assembly and the redesigned assembly, in order to compare them. Manufacturing of one of the component was done in PTC Creo, where the tool path was assigned to the lever part and 3 different operations were carried on it. First was the drilling of hole, second was the volume roughing using a tool with bigger diameter, and third was the surface finishing using a tool for a smaller diameter for smoothness of the part. This figure shows the manufacturing tool path done in PTC Creo. As a conclusion, we satisfactorily completed the target of project without violating the main purpose of the product. Design for manufacturing and design for assembly were implemented brilliantly in the proposed design, even which in some proportion improved the functional design. The modification of the valve is a better design for manufacturing and assembly capabilities, which finally lead to reduction of overall cost of product. Thank you.